Okay, the final question on the problem-solving worksheet. The diagram shows a cylinder with a diameter of 30 and a height of 25, and I want the volume of the cylinder. So first things first, we have to know the volume of a cylinder formula, which is volume equals pi r squared h. And the picture that goes along with this, there's my cylinder, there's h, the height of the cylinder, and r, the radius. Pi r squared h. Like all prisms, it is simply the area of the face times the depth. Now, the thing that makes this question a little bit tricky is not the pi, that's easy enough, we've got a calculator, but the fact that they don't tell me the radius. There's a trap. They tell me the diameter. And the diameter is all the way across, and I just want halfway across. I just want the radius. It's pretty straightforward to realize that it's 15 centimeters, but you've got to watch out and make sure you actually spot this. Otherwise you'll lose marks. So I'm going to substitute into my formula now. Volume equals pi times the radius, which is 15 squared, times the height, which is 25. Now in terms of what happens next, all of this can be put into the calculator. And because it involves pi, I'm going to have to use my calculator. And I'm getting 17671.46 centimeters cubed. They don't ask me to round my answer at all, so 2 decimal places will probably be fine. 17671.46. So the formula looks complicated, but it works the same way as every other formula. We just put numbers in and work things out. The tricky bit here is realizing they haven't given us exactly what we need. They've given me the diameter and I needed to convert that to a radius before I could use the formula. Now let's look at the next part of the question. The cylinder is placed inside a cuboid, and the cylinder touches all the faces of the cuboid. I want to calculate the surface area of the cuboid. This is quite a scary looking question, I think. But they've given me most of the information I need already. It's actually going to be pretty straightforward. If it touches all the sides, then this length of the cuboid down here must be 30 centimeters, just like the diameter of the circle. And this side over here must be 30 centimeters as well, because the diameter goes in every direction. That's 30 centimeters. That's 30 centimeters. And if it fits perfectly inside as they show, then the height of the cuboid must be 25 centimeters, like so. So once we've figured that out, it's just a surface area of a cuboid question. And for me, the easiest way to do this is to make a little picture. Here's the base of the cuboid. I'm going to draw a flap for each side. So my base over here is drawn like this. There's a flap for each side, and then I'm going to put a lid on top over there. So there's my lid, like so. If we look at the measurements on the 3D diagram, we realize this is 30 and 30. So the area of this section is 30 times 30, which is 900 centimeters squared. That must also be the same for the base. Each side now is 30 times 25. Remember, this is 30 and this is 25. So 30 times 25 is 750, and that must be the same for each side. 750 over here, 750 over here, 750 over here, because each of these sides is 30 and each of these sides is 25. So that surface area is equal to 900 plus 900 for the base and the top, plus 750 plus 750 plus 750 plus 750 for each of the sides. This all adds up to 3,000, so altogether we've got 4,800 centimeters squared. So the actual adding and calculating part of this question is very straightforward. It's a case of realizing that that diameter of the cylinder must be the same as the length of the cuboid. And that's quite tricky. But hopefully that makes sense and we understand what's going on.